A differential band brake is shown in the figure. The width and thickness of the steel band are 50 mm and 3 mm respectively and is to be operated at the maximum band pressure of 1000 kilopascal. The coefficient of friction between the friction lining and brake drum is 0.3. So here is the given diagram. Here it is a band brake of radius 125 mm, and here it is the load is applied at a distance of 500 mm from the band, one side band, and here it is a common data question. It consists two questions. Here the first question is what is the limiting value of force P, and here the second question is calculate the torque capacity of the brake. So here if you observe here the drum rotating in anti-clockwise direction, so that means generally the tight side of the brake occurs, the tight side of the band occurs at this side and the slack side occurs at this side. So that this is considered as tight side and this is considered as slack side, and generally maximum tension occurs on the tight side and minimum tension occurs on the slack side. Now consider the free body diagram of this band brake. So this is the free body diagram of the given problem. So here 180 degrees is the angle of overlap, and here it is T1 is the tension on tight side and T2 is the tension on slack side. So here first we will have to find out the maximum tension in the band, that is T1 is given by the maximum pressure applied on the belt is given as 1000 kilopascal, and the tight side tension is equal to P max into R into W, where R is the radius of the band and W is the width of the band, and here P max is given by 1000 kilopascal into 10 cube, it converts in Newton per meter square, and R is the radius of the band, it is 1.125 meter, and W is the width of the band, that is 50 mm, that is 0.05. So which gives a value of 6250 Newton. So this is the maximum tension occurs in the band. Now we will have to find out the minimum tension, that is T2, and the ratio of T1 and T2 is given as e power of mu theta, where mu is the coefficient of friction between the friction lining and brake drum, and here theta is the angle of overlap, and here theta is equal to 180 degrees. Just convert it into radians, that is pi by 180, which gives pi radians, and here mu is given as 0.3. Now substitute all the values here. So T2 is equal to T1 by 6250 by e power of 0.3 into pi. So which gives a value of 2435.4 Newton. So these are the T1 and T2 values. Now take the moments about the fulcrum of all these forces, which gives P into 625 minus T1 into 125 plus T2 into 125, which is equal to 0. So from this equation here the T1 and T2 are known values, so we can find out P, that is equal to 763 Newton. So in the options, right option is C. For the first question the right option is C, that is the first question is here what is the limiting value of force P. So here it is the limiting value of force P, that is equal to 763 Newtons, and in the option the right option is C. Now we will have to find out the torque capacity of the brake. Torque capacity of the brake is equal to T1 minus T2 into R. So which is equal to T1 is 6250 minus 2435.4 into R is the 125 mm or 0.125 meters. So which gives a value of 477 Newton meter, and in the option the right option is B. B is the right answer for the second question. 3 pipes 300 meter long, 30 centimeter diameter, 150 meter long, 20 centimeter diameter, and 200 meter long and 25 centimeter diameter are connected in series in the same order. Pipe having 30 centimeter connected to reservoir. Water level in the reservoir is 15 meter above the pipe axis, which is horizontal. The respective friction factors for three pipes are 0.018, 0.02 and 0.019. Neglect minor losses. Here it is a linked answer question. It consists two questions in such a way that second question answer depends on the first question. Here the first question is the flow rate in meter cube per second is, and the second question is if the three pipes are replaced by a single pipe of friction factor 0.016 to give the same discharge, the diameter of the pipe would be. So coming to the first question, we will have to find out the flow rate. Here the known values are the total head and diameter and length of the pipes and friction factor. So here the total head is equal to the head loss in each pipe, the sum of the head loss in each pipes, so which is given by F1 L1 Q square by 12.1 into D1 power of 5 plus F2 L2 Q square by 12.1 into D2 power of 5 plus F3 L3 Q square by 12.1 into D3 power of 5. So here F1 L1 D1 are known values. In this also FL and D are known values. Here also FL and D are known values. Substitute all these values and equate it to the total head, that is 15 meters, so that we can get here Q value that is equal to 0.10825 meter cube per second. So in the option, the right option is B. And coming to the second question, if these three pipes are replaced by a single pipe of friction factor 0.016, then diameter of the pipe would be. So here if it is replaced by a single pipe, then here equivalent length and equivalent diameter, let us say DE whole power of 5. Now substitute this discharge into this equation, and FE is given value and LE is the given value. So here the equivalent length we will have to take the total length of the three pipes, that is 200 meter plus 150 meter plus 300 meter. So here from this equation you can find out the equivalent diameter, so which is equal to 0.232 meters or 23.2 centimeters. And in the options, the right option is C. C is the right answer.